we can start.
Yeah, I think we should start.
Yes.
Okay. Thank you, Professor. Good afternoon, everyone. On behalf of the organizing team, I would like to welcome everyone to this fourth technical session of the workshop. At the outset, I sincerely apologize because due to some serious technical issue, we could not start this program on time. Uh, in this technical session, we have among us as resource person, Dr. Manas Pratim Borman sir. He is an associate professor in the Department of Statistics, Discrete University. And he will be dealing with us on use and interpretation of data in MS Excel. His area of interest are biostatistics, epidemiology, and population studies. Sir has completed research projects funded by UGC. He has a number of research-based publications in journals of national and international repute. He have offered research guidance to a number of PhD and MPhil scholars. He has served as a resource person in various workshops and conferences, basically associated to research methodology. And we are truly privileged to have Dr. Manas Pratim Burman sir as our resource person in this technical session. I would like to request sir to take over the session. Dr. Burman sir, please unmute yourself.
Okay, am I audible?
Yes, sir, you are audible. Please carry on.
Hello, everybody. Good evening. I'm Dr. Manas Pratim Burman from Department of Statistics, Discrete University. Today, I will talk on this. I would like to thank the organizing committee for giving me the opportunity to talk in this platform. Okay, so my topic of I will give you a series of lectures. Today I will give data analysis by using MS Excel. Okay, MS Excel is a very powerful tool. I'll show you how to do data analysis, and you know that MS Excel is extensively used in offices, in business establishments. But I'll show you MS Excel how it can be used in statistical perspective. Okay, so today we'll talk about MS Excel. With the help of MS Excel, we can do a lot of statistical work. So here I have given some name of some softwares, MS Excel, then SPSS. Tomorrow I'll talk on SPSS. Then API Info. This is a free software, API Info. It was developed by Center for Disease Control and Prevention, and you can freely download it from the internet. It is very good for categorical data analysis. A lot of categorical analysis can be done by using EP Info. Most of the important thing is that it is fully free software. Okay, then Strata and Minitab. This can be considered as an equivalent to SPSS. These two have a lot of, but they are not free. Then we have R. R is very popular now. We can do a lot of calculation. Most of the calculation can be done in R, and it is also free. You can download it from the internet very easily. So today we'll talk on Excel. Okay, let us open Excel. I think everybody knows some bit of Excel. So I open Excel. So this is Excel, and it consists of lot of number of triangles. These are all triangles. This is one triangle. This is sorry, not triangle, rectangles. So it consists of number of rectangles. Okay, and these are called cells. Okay, and the SPSS is called a spreadsheet because we can do calculations here. A lot of calculations can be done by using Excel. Okay, and these are the menus. I think all of you know about these things. With the help of these menus, we can do a lot of things. We can make graphs, we can make calculations, we can make, I'll show you one of those things, okay? Then these are called cells, right? And these cells can be resized, it can be increased, or it can be it can make, you can change the size of the cell. Okay. Now, in these cells, we can write any formula. Okay. In these cells, we can write any formula. To write any formula, we have to first click the equal sign. If you put the equal sign, then only you can write the formula. Otherwise, it will be not considered as a formula. Or to do any calculation in Excel, you have to first click the equal sign. Suppose I put some value. Okay, you cannot calculate without the equal sign, it cannot be calculated. Suppose 45 plus 89, 78. Okay, it is not calculated because I have not put the equal sign. So to do any calculation, I have to first put the equal sign here. Then it will calculate. Then Excel will know that this is a calculation. See, so first of all, we need to put the equal sign. Okay, so but with the help of Excel, and these are the symbols. You know, I think everybody knows. For addition, this, subtraction, this, for multiplication, this symbol is used. Division, this symbol is used. For power, exponent, this symbol is used. To find a square root, we have to use this symbol. For absolute value, this is the symbol, and for parentheses, this is the symbol. So these are some symbols that are supported by R for doing calculations. Now, these are some examples of calculation. Suppose I want to calculate 1.96. So first of all, I have to put equal sign. 1.96 into, for multiplication, this is the symbol, and 2.5. So click enter. So this is the value. Okay. Suppose I want to find the square root. Suppose this is the formula, second formula, 2.5 divided by, for finding the square root, I have to click there is a function for a square root in Excel. That function is called SQRT. Okay, this is called, suppose I want to find the square root of 40. So this is the formula. So like this, I have to, this is the, suppose I want to calculate this one, 2.5 divided by the square root of 40. I want to calculate this. So it will be like, this is the formula. This is called the formula bar. Here in this cell, we can see the values, but this behind this value we have some formula, and this formula is shown in the formula bar. This is called a formula bar. Okay, so the value is shown in the cell, and the formula using to calculate the value is seen in the formula bar, right? So suppose I want to calculate this third one, 1.96 into 2.5 divided by 40. So it will be like this. Here I have to use parentheses. So 1.96 multiplication, then 2.5 divided by SQRT into 40, like this. So this is the calculation. It will be calculated like this. Okay. So if you try it, you can do it very easily. So you have to be very, very careful while giving the parentheses. Okay. People who have mathematical background, I think they understand this one. And the use of parentheses is very important while doing the calculation. Okay. Now, let's talk about the cells. Okay, so Excel is consist of cells, rectangles. Okay, these rectangles, every rectangles, this cells has a particular name. All the cells has a unique name. This cell has a name A1. This cell has a name AB1. This cell has a name AC1. So this cell, suppose it has this name is called cell reference, right? Cell reference. So cell reference for this cell, this highlighted cell is D6. The cell reference for this highlighted cell is A6. So this cell reference is very, very important for doing the calculation. Okay. while calculating the values, we should use the cell reference, not the actual values. I'll show you one thing. Okay, suppose I put some value here, right? So here we will put some value. Now I want to add the three values. I want to add all the three values, right? So first of all, what we have to do, I have to first give the equal sign. Otherwise, Excel will not take as a formula, not take as a calculation. So I can write like this: 1, 2, 3 plus 23 plus 78. Enter. Okay. I can write like this, no problem. But I can do in another way also. I can give not, I cannot, I may give the cell reference although not the actual value. Suppose the cell reference for this value is A1 plus A2. This is the A2 plus this is the A3. You see, the value will be same. So either we can use the original value or we can use the cell reference. Okay, both are is going to work. But if you use cell reference, there are a lot of advantages are available. Okay, I'll show you what are the advantages of using cell reference. Okay, suppose I have some, I put again some values. I have, this is the first series of values. I have some series of values, suppose. Okay. Now, suppose I want to add these values separately. Okay. So what I have to do, first of all, I have to write the cell. Suppose I write like this. I will write the actual values: 456 plus 78 plus 56. Okay. Okay, it will no problem. It will work. Suppose now I give the cell reference. Cell reference is A1 plus A2 plus A3 plus A4. Now the results are not A1 to A3, A4. This should be 28. See, I put some. This should be 23. There is always a possibility of entering the data. There are some errors maybe there, but if I give the cell reference, that it will be there is no possibility of errors, right? Now here I have gave the cell reference now. So for calculate, if I use this, if I use actual values for doing the calculation, then I have to do the same calculation for all this series. But here I have used the cell reference now. So what I can do, I can just copy the formula to the other cells. For that means I don't have to write the formulas for this and this. Okay, I just go select this one, go to the side, this side, okay, and drag it. Okay, you will get the result automatically. But if you use this way, then you cannot drag it. You cannot get the values for the others. You have to do the calculation for all the series. So it's a very good benefit of using Excel, using cell reference while calculating MS Excel. You can change some values also here. If I change some values, suppose I have entered it wrongly, then it will be corrected. Okay, it will be corrected. But here, when I use the original value, it will remain same. But if I suppose 78, it should be 90. I wrongly entered. Then if I enter this, then it will be changed here in the cell reference. So it will be better if you use the cell reference rather than using the original value for calculating. Okay, I'll show you one more thing. Suppose this is the information on income. Okay, I have taken some data. Suppose this is suppose this is the this. Let us copy it first. Then I will explain it later. Suppose these are some incomes of individuals, right? Now I have to find the annual income. This is the multi income. Suppose I want to find the annual income. So what I have to do, I have to multiply it by 12. So if I do it by using the original value, then I have, suppose I multiply this 10,000 into 12. Then I have to do this same operation for all these values. If I use the cell reference, then I don't need to do the calculation again and again. I just drag it. I just copy the formula. Then suppose A2. This is 10,000 means A2 into 12, right? Enter. You see. Now drag it. So you don't need to write the formula again and again. Okay. So these are some. I think most of the people know about this thing. This is now I want to go to the statistics, how Excel can be used to do statistical calculations, right? Now, you see, statistical analysis is basically divided into two parts. One is descriptive statistics, one is inferential statistics. I don't want to take much time about this because Hazarika sir, Professor Jiten Hazarika will deliver on this tomorrow. So I will show you how descriptive statistics and inferential statistics can be done by using Excel. Okay, so different descriptive, I think most of the people know about this thing. So different descriptive statistics are frequency tables, then the frequency tables, suppose one-way table, two-way table, class intervals. I will show you how to make one-way table, two-way table, class intervals. Then descriptive different measures are there, central tendency, measures of dispersion, correlation. Okay, so I will show you how to make these things. Then variety of graphs can be made in Excel. So I will show you how to make bar graphs, pie graphs, Scatterplot, line graphs, and I'll also show how to do inferential statistics using Excel. Okay. So Excel is basically divided into two parts. One is descriptive statistics. Statistics is divided into two parts. One is descriptive statistics. One is inferential. I'll show you one thing. Suppose this is one of my paper. While suppose you collect this paper is based on actually factor associated with immunization coverage of children in Assam. Okay, here we study what are the factors which affect the immunization coverage. Okay, this paper was published in Journal of Tropical Predictics. So here we collect information on immunization of the children, but and here we use, see, first of all I want to show you that before using the inferential statistics, we always have to describe our data. Suppose for studying this, we have collected some data, na? So to present, to get interpretation about this study, first of all, our objective should be to describe our data, what type of data we have collected. So you see, we have collected information about 336 male, 300 female, about 280 females. Now location is like this. So first objective will be our objective should be to describe our data. So description of the data can be done by using descriptive statistics, by using graphs. Here I use these pie graphs and frequency tables, and we can make cross table. This is a cross table, type 2 table. This one a type. This is one a. These are type 2 table, two-way table actually. Okay, I'll show you how to make two-way tables in Excel. Okay, so when you collect some data for you to do any study, first of all you have to describe your data. You have to give the profile of your data. So that can be done by using descriptive statistics. So I will show you how to make descriptive statistics. Okay. Suppose I have some data. So suppose these are the, I have given a very small data set. Suppose I collected data on name of the, I collected the name of the person, his residential status, whether he is coming from rural area or urban area, his suppose age, okay, his sex, his education, his income. So these are the information that I suppose I collected from the from a sample of size suppose 300. So I take a sample of size 300, and from this sample I calculated collected this information. Okay. Now here in this questionnaire, I will talk about it later also, and Hazarika sir also I think will talk about this. Here we have two type of variables. Okay. Suppose variables means suppose when we collect information in statistics, I will explain what is variable. We call it in statistics, we call it variable. Suppose age, I am collecting age. So one person said that my age maybe 24. Someone said my age 42. So for every person, we have get different values. So it varies every time, right? So we call it variables. So these are all variables. Name of the respondent, residential status, this is also a variable, age of the respondent, and sex of the respondent. For all the person, it varies every time. Someone may be a male, someone may be female, like this. Education may be literate, someone may be primary. So these are all variables. And out of these all variables, we have two different type of variables are there. One is discrete, one is continuous. So residential status, you see, this is actually a categorical variable. Here we have only two categories, rural or urban. Okay, so if I ask a person something, whether your residential status is, then he will say either rural or urban. But for age, he may say anything. My age may be 24.5 years. My age may be suppose 47.7 years, like this. So here we don't have any decimal places. It may be either rural or urban. This type of variables will call discrete, and it is a categorical variable, and we call it discrete variables. Okay. And these are this is the age. Age is a age, maybe age or income. These are called continuous variable. It may take any value. Suppose my income is 10,540 rupees, like this. Or it may come also in decimal places. When you got values in decimal places, then it will be called a continuous variable. Suppose height 4.5 feet. Suppose weight 47.5 kg, like this. So that type of variables are called continuous variables. And when we have only categorical type of data, that is called discrete variable. Suppose now this data is a qualitative data, na? Residential status, male, female, or education, it's a qualitative data. It has quality. It is not numeric, but statistics is based on numerical data only. Okay, I'll talk you tomorrow also about this. So what we have to do, I have to make them numeric. I cannot lose this data. Na? This gives us a lot of information, so I cannot lose it because it is qualitative. So what we have to do, we have to make them numeric by assigning numerical codes. So I have given some codes here. So you see, so this is the way we can make the qualitative data to the numerical data by using some codes. It has number of categories, ordinal, nominal, like this. Professor Jiten Hazarika will talk about it tomorrow. The information about knowledge of data is very, very essential for doing proper statistical analysis. Okay, you need to know what type of data is this, because we have, we have number of statistical methods are available, hundreds of statistical methods are available, but the most important thing is that you have to choose the proper method, because all the methods are not applicable to all type of data. Okay, you must know what type of data is this and what type of analysis we have to use. So knowledge of data is very, very important while doing the statistical analysis. I'll give you an example. Okay, so this is the categories. 0 means rural, 1 means urban, sex is 0 means male, 1 means female, and education is 1 is illiterate, second is primary, like this. So we make this calculation. Now, so we collect this data and we arrange the data, this data in Excel format. Okay, so this is the data, right? We always enter the data like this in Excel. These are rows. This is the first row. This is the second row. This is the third row. This is the fourth row, and these are columns. Okay, in one column you have to enter one variable. So name is a variable. You have to enter the name of all the person in this column only. Okay, and in the second column we enter location, and we have to give the numerical codes. This person is from rural area because rural is 0. Okay, and this his age is. So in the rows we have to enter all the information of a particular person. So suppose this this is the first name of the first person. His location is rural. His age is 60 years. His sex is suppose one is I think female. Education is 2, primary, and income is this. Okay, so this is the way you have to enter the data in Excel. Okay, so I have information on 300 individual. My sample size is 300. It is 301 because the first row is devoted to the name of the variable. It starts from 2, na? That's why it is 300. Okay, so this is the way I have to make the analyze enter the data, right? Like this. Okay, so in the SPSS also you have to enter the data in the same way. Okay, if I enter the data in Excel, and you can very easily convert it to SPSS also. Okay, most of the people enter the data in Excel, then it exported it to SPSS. Okay, right. Now here we have three types of this variable have nothing to do with our analysis because this is a alphabetical variable. This is a name. We cannot do any analysis with names. So these are the important variables for us. Now we have to do the analysis with the help of this variable. I'll show you how to do statistical analysis by using this table. Now we have 3 categorical variables. See this one, first one, location, then sex, then education. The first one has 2 categories only, 0 and 1. 0 means rural, 1 means urban. The sex variable has 2 categories, 1 and 0. 0 means male, 1 means female. And education, we have I think 4 or 5 categories. 1 for illiterate, 2 for primary, 3 for up to SSLC, 4 for HS, and 5 for graduate and above. So these are the categories, and these 2 variables are continuous variable. Here we don't have decimal places, but actually this is rounded up. Age is actually continuous variable, but we never give our age accurately, na? Because a person cannot be exactly 60 years of age. He may be 60.5. His age may be 60 years, 2 months, 2 months, 5 days, like this. It will come in decimal places actually, but we rounded it up, so it becomes there is no decimal places, but actually it is a continuous variable. Okay, so now we have to let us do descriptive analysis by using Excel. And I forgot one thing. In Excel we have lot of functions are there. Okay, so there are some functions of these are some functions that are supported by Excel to do the calculation. So if I want to find the minimum value, maximum value, the function is max. And if I want to find the minimum value, the function is min data range. So if I want to find the arithmetic mean of the data, so the function is average, AVERAGE. We have to type the spelling accurately, then data range. So for median, this is the formula. For mode, this is the formula. For variance, this is the formula. VAR, I'll show you how to calculate this. This is standard deviation, STDEV. The formula is, the formula for standard deviation is STDEV bracket data range. Then to find the correlation, we have the formula CORREL, data array 1, data array 2. And then frequency distribution for continuous data. So this I will show you how to do this. Frequency data array, comma beans array, right? So frequency for categorical data, countif, and range. And conditional state. These are some of the statements. Excel support number of functions, but these are the functions can be used for calculating the statistical measures. Okay, mean, median, mode, standard deviation, variance, correlation. So frequency table we can make. Okay, so I'll show you one by one. Now, first of all, we have, you see, we have here two type of variable. One is discrete. This is a discrete variable. This is a discrete variable. This is a discrete variable, because here it cannot support decimal places, right? It cannot support. It may be 1 or 2. It cannot be 0.5 or 1.2 like this. So it is a discrete variable. For discrete variable, can we calculate mean, arithmetic mean? Can we calculate it? Can we calculate arithmetic mean for discrete variable? Suppose gender. I am taking gender, information on gender. Okay. So first person is suppose 0. 0 means male. Second person is female. Third person is suppose 0 male. Fourth person is female. Fifth person is suppose male. Okay. So suppose I collect information on 5 individuals, and these are the first one is 0, second one is 1, third one is 0, fourth one is 1. You understand, I think. Now, if I want to calculate the arithmetic mean, so what is the formula for arithmetic mean? In arithmetic mean, what we have to do, we have to add all the values, then I have to divide it by the total number of observations. So add all the values means 0 plus 1, 0 plus 1 plus 0, like this. I have to add all these values. If I add this, it will be come around 2. And there are how many observations? 5 observations. Though it will be 2 divided by 5. So what will be the value? 2 divided by 5 means 2 divided 5 means it will be what? 0.4, like this. It will be 0.4. That means the mean gender is 0.4. Does it have any meaning? Suppose mean income is suppose 40,000. That means if I say that the mean income of my group, that group I have taken is 40,000, that means we can understand that most of the people are around 40,000 age of 40,000 income. Okay, the middle point is 40,000, and all the people are around 40,000. Their income is around 40,000, but my gender is 0.4. Does it have any meaning? No. So for categorical type of data, we cannot calculate the arithmetic mean. So that's why I'm telling it that the knowledge of the data is very, very important for using the proper statistical method. Okay. Now, for suppose for let us do the calculation for continuous variable first. Okay. For continuous, for let us do it for discrete variable. So for discrete variable, what type of statistical analysis we can do? We can make frequency tables. Let us see. So descriptive statistics. So we can make one-way frequency table and two-way frequency table by using for discrete data. Okay, I'll show you how to make one-way frequency table or two-way frequency tables. And for continuous data, we can make class intervals. Okay, now we cannot calculate measure of central tendency and dispersion for categorical data. I have shown you that mean is not appropriate for doing calculation, and correlation I will show you later. And bar graph we can make, pie graph we can make for discrete variable. Okay, so let us do the analysis with discrete variable. So suppose I copy this discrete variable to a different sheet. So these are the sheets. I am on sheet 1. Now I put the values in sheet 2, suppose. So I think you know, everybody knows this sheet 1, sheet 2 matters. So sheet paste. So these are my variable. Now what I have to do, I have to make a frequency table like this. You see, suppose education, illiterate, how many people? So our purpose is to summarize the data. Okay, summarize the data so that everybody can understand what type of data we have collected, right? So by using this type of, this is a one-way table, no? Because it has only rows. Here it is, we have two-way tables. Here we see we have both rows and columns. In the rows we have the education, and in columns we have gender. So this is called one-way table, and this is called two-way table, right? So in one-way table we have only rows or columns, either rows or columns. Okay. So in two-way table we have both rows and columns. Okay. So now I'll show you how to make one-way table in Excel. Okay. So let us make one-way table. So for making one-way table, I have to use this function. This function, Countif function. Okay, you can write it. Let us pause this for some time and you can write it. Write the function. These functions are very, very important. I'll show you how to apply these functions. Okay, so I pause it for 1 minute and you can write, if it is possible, you can write it. So for doing for constructing a one-way table, I will use this function Countif, C-O-U-N-T-I-F, Countif. In bracket, we have range, comma, criteria. Okay. Range means data range, from where the data where it exists. Okay, and criteria. So these are the some of the functions. Okay. Now this is the function I am going to use, Countif range criteria, right? Okay. So I'll make the table here. So location, residential status. So location is rural and urban. Okay. Here I have to put the frequency. And here I have to put the percentage. Okay. Right. Here I have to put the frequency, like the same as like this table. Like this table. Okay. Here in the first row, we have the different categories, related, primary, or rural, urban. Here we have what? The frequencies, and here we have percentages. Okay. Now I am going to use the Countif function. So for now, I am going to count the number of person in the rural area. How many? Once rural means 0. How many rural people are here in this data set? I have how many observations? 300 observations. You see, I have 300 observations. I have 300 observations, right? Okay. Now, let us write the function Countif, C-O-U-N-T-I-F, Countif, bracket, right? Now, but you see here, we have the function. It is automatically appear the function range, comma, criteria. Here, if you write the function properly, then it will find the function will appear automatically. Countif range, comma, criteria. So range means what? Range means from where this, from starting to the last, from where the data is there. Okay. So my first cell where the data is, my first cell is A2. A2 is my first cell. From data started here and it goes up to A301, right? So I have to write like this, A2 colon. A2 colon means 2. A301. Okay. A22 A301. This is the range. A22 A301. This is the range. That means our data is from A2 to A301, comma criteria. So I have to put a comma here, and criteria means for which we are going to count it. Okay, so we are going to count it for 0. 0 means real. Okay, so I have to put 0 here. Then close the parenthesis, enter. So how many people are here? We have in our 300 sample, we have 228 people who are from the rural area. Now I have to do the same process for the urban also. So Countif bracket, data range is from A2 colon A301 comma criteria. In this time criteria will be 1. 1 means urban. Enter. So how many people? 72 people. The total should be 300. So total, if I do the total, it should be 300. You see, sum this plus this, 300. Okay. So, okay. Now equal sign. I have to make the percentage. So how the percentage can be done? So rural, for rural area, this divided by 300. This value divided by 300 into 100. That will be the formula for this divided by 300 into 100. So how many people? 76 people. Okay. Now for this, we have to write the formula 72 or E2, E4 divided by 300 into 100. 24. Total should be in percentage. The total should be always equal to 100. So you can now, if I copy this to the Word, because we have to make our reports, we have to write our reports in Word. So we always have to copy it to the two words. No, it can be very easily copied to the words. So Control V. You see, but here the borders are not there. To get the borders, we have to do one thing. We have to select this and click here and all borders. Okay. Now if I copy it and paste it, you see, this is the table. You can present this table now. How many people? 228 people, and urban 72 people, right? It's very easy. Okay. Now let us make this table for suppose education. So let us copy this column here. So my data range is from B2 to B301. B301. Okay. So now education. Illiterate, primary, college. So frequency and percentage. Okay. So write Countif B2 colon B301 comma illiterate is 1. So how many illiterate is there? 3. Then Countif B2 colon B301 comma 2. 2 means primary education. So 92 people. Then Countif B2 colon B301 comma 3. So up to SSLC, how many people? 153. So Countif bracket B2 colon sorry, B301 comma 4 and college Countif B2 colon B301 comma, I think it is 1 2 3 4 5. Okay, so these are the frequencies. How many people are illiterate? 3. There are 92 people who completed primary education like this. Then we have to total should be equal to 300 because I have collected information on 300 individuals. So select this sum is a function. Okay, I'll show you how the use of sum. Sum is a function that can be used to add all the values. Okay, 300. So percentage is this divided by 300 into 100. So 1% like this. Okay. So this is the table. So first of all, I have to put the borders here. Then I can copy it to Word very easily. You see this. Okay. It can be adjusted very easily. Okay. Now, what type of graphs we can make from this table? So here we have graphs, bar graphs and pie graphs. These two graphs can be constructed for this type of table, for one-way table. If I have only one variable and I want to make the frequencies, then I can use bar chart and pie chart. We have other bar charts also, suppose multiple bar chart, stack bar chart. I'll show you, but multiple bar chart is used when we have two variables. When I am studying the relationship between two variables, then multiple bar chart can be used. Now if I use only single variable, then I have to use a single bar chart, simple bar chart. Okay, so let us make bar chart. So to make any chart, just copy it, select the area. Okay, you can use the percentage also. So let us, I'm making the chart for number values. Okay, then go to bar, this. So this is the bar chart. Okay, it's very easy. You can give the name of the schools also. Okay, so bar chart for location also we can make bar chart. Insert bar column like this. Oh, here we have. Now here I have also selected the percentage. That's why it come like this. It is not there. Percentage cannot. Both percentage original values cannot be used. So I select this one. Either you select percentage or this, right? Insert column bar. Okay, so this is a table bar chart. Okay, now if I want to make a two-way table, okay, I want to make a two-way table. Two-way table means like this. This one. Here in rows, we have education, different categories of education. In columns, we have gender, suppose male and female. So it is actually here with the help of this table, we can study the relationship between gender and education. This type of table is very it will give lot of information. I will show you while doing SPSS how this type of table can give us lot of information. Okay, so it shows the relationship between actually gender and illiteration. So we have 3 illiterate people. Out of this, 2 are females, 1 are males. That means female are more educated. In this table we can see it. Here also you see there are out of primary people 48 are male. So it gives us a relationship between these two variables, education and gender. Okay, so this type of variables are very informative, right? So let us make a table for suppose location and education. I will make table for location and education. So for that, first of all, I have to go to insert. Okay. Then I have to go to pivot table. You see. So I will show you one more time. You just select insert. Okay. Then this here I am constructing a two-way table. Okay. I think everybody understand this. So for that, I have to get to insert, then pivot table. Okay. Here we have two options. One is pivot table, one is pivot chart. Let us click pivot table. I want to make table. Na? So select. Okay. Now, first of all, I have to select this. Let us select this whole area. Okay. Go to insert pivot table. Okay. First of all, you have to, the most important thing, you have to select the two variables, right? Okay. Without selecting, you cannot make the table. So you select pivot table, click pivot table. You see the data range comes here. It is from A1 to B301. A1 is for location. So this gives us the data range. So seat 2, we have in seat 2, you see seat 2, it is written here. We have in seat 2, and it is from A1 to B301. This shows us the data range from where this data, from where to where this data exists. Okay, then click OK. Okay, now you see in this side we have come to this here. Here we have put the rows and columns. Okay, so in rows, what in this you see in the rows what we have. In the rows what we have. In the rows we have education, different categories of education, and in columns we have different categories of gender. So in columns we have to put the gender. In rows we have to calculate put the education. Okay. Okay. So you see in education these are the two different variables here. Okay. In this right side, everybody's I think understand this. So we have to put education. We have to drag education to row. You see, it comes here, and these are the different categories of education. And we have to put select this and put it into columns. Okay. Now you see in the rows we have different categories of education. One means illiterate, two means primary. In this side, three means up to SSLC, four means ACS, like this. And in columns we have male and females. Now either location or education you have to select and put it here. Put these values. Okay, right here. The sum or count of values will be done. So I put education here. Now this is the table. Now is this correct? This table is correct. This table is not correct because the total should be 300. Then what is the problem here? Problem is because we selected here. You see here this side, in this value we selected sum, but it is not sum. Na? If I use the function sum, then it will be different because there will be 3 zeros. Okay, so 0 plus 0 plus 0 will be always 0. So actually this is in frequency table. We are not summing anything. We are not adding anything. We are counting. Okay, we have to count how many people are there. So we have to select this, change this one. So click here. Value field settings. You go to value field settings, then you see this window comes. So here we have to select. Now it is selected. This sum is selected. Now you have to select count. Then click OK. Okay. Now you see there are how many people? 300 people. Okay. Okay. So this is the table. So how in the, we have taken values rural and urban. So there are 3 rural peoples. All of them are illiterate. Okay. So here if I change like this, first one is illiterate, then primary, then up to SSLC, then HS, then graduate. And here for we are making the we are making tables for location and education, right? So location is 0 means rural, urban means 1. So this is the table. You see, there are 3 illiterate people, all belongs to the rural area. There are 92 primary people who have completed primary education, and out of them 75 belong to rural area and 17 belongs to urban area. There are 153 people who completed up to SSLC. Out of that 113 people from the rural area and 40 people from urban area. Okay, like this. Then there are 34 people in HS. Out of this, 22 people are from rural area and 12 people from urban area. Okay, I will show this one more time. This table is very important. Okay, now let us make this table to a table with gender and education. Let us copy this. Okay, so I want to make a two-way table for sex and education. Okay, so first of all, I have to select the area, go to insert, pivot table, then it shows us the range of the data, then click OK. You see in the right side, we have the options sex and education. So education I put in rows, sex is I put in columns, right? And to count the values, let us put education here. If we put sex also, there will be no problem. Then you have to change this setting. Now it is by default, it is sum, but here we have to count the values, not sum it. Okay, so click here, then count it. You see now, this is the table. Okay, now from this table, we can make what? Multiple bar graph or stack bar graph. So let us write illiterate primary it is gender, rural. 0 means male, 1 means female. Now from this table, what type of graph we can make? We can make multiple bar graph. Okay, so for that I have to select this whole area, this. I have to select this whole area, then go to insert, then columns. Okay, column graph. Then this is the multiple bar graph. Select. You see, this is the multiple bar graph. Okay. So here we have a relationship between how males and females are educated. Education of male and female can be seen separately in this. This gives us a relationship between gender and education. Okay. So you want to, if you want to add the title, if you want to add title to the graph, so for that you have to go to layout. You have to go to layout, then add chart title. Okay, above chart. So relationship between gender and education. Okay, now if you want to specify what is the x-axis, suppose I want to put a education here, because this shows the x, this is the x-axis, this is the y-axis. So x-axis shows the education and y-axis shows the number of gender. Okay, so if I want to put this, for that I have to just go to axis title. Okay, then primary horizontal axis. So this is a horizontal axis. To give the name of this axis, I have to go to primary horizontal axis. Then title below axis. Okay, so you see here, it comes here, so it gives education. Okay, it will be like this, education. You see, and if I want to give the gender here, for that I also have to go to layout, then axis, vertical axis. This axis is vertical, so we have to select this one, vertical axis, then rotate title. Okay, so here I have to put the gender. So this is the graph for multiple bar diagram. Okay, now you can make stacked graph also for this. So for making stacked graph, you have to just select it, go to insert, then columns, then this type of graph is called stack. So this is the stack graph. Okay, so when we have two variables, you want to study the relationship between two variables, then you have to make two-way tables, and also we can make graphs that two-way table like this, and we can make graphs. It's called a multiple bar graph or stack bar graph. It can be very easily made in Excel. Okay, so I have to move quickly because I have to show a lot of things. Okay, so you have to practice it, otherwise you are going to forget everything. Okay, now suppose now what type of graph we can make. So this is the way we can analyze the descriptive discrete variables, categorical variables. We can make table and graphs. We can make one-way table if I want to study only single variable. So this type of one-way table we can make. And for if I want to study the relationship between two variables, then I have to make this type of two-way tables, and we can make bar graphs, and I'll show you pie graph also. So pie graph. So pie graph is also very informative. So for making pie graph, suppose let us make the table again. Suppose sex, frequency, male, female. So it will be Countif. Same process. So D2, sex in the D2 column. Na? So sex is in D2 here, this side, D2 colon D301, comma 0. 0 means male. And so how many males are there? 142 males. And Countif D2 colon D301, comma 1. So this is the male and female. Total should be 300. So select this one to make pie graph. Click on insert, go to pie. You can make 3D pie also. So this is a 3D. So these are the number of males and this is number of females. You can make a lot of modifications here also. Okay, we don't have so much time to show all this modification. You can try it, no problem, I think. And you can go to the YouTube also. There are a lot of videos are there. Now I'll show you an important graph that is called line graph. Okay, line graph is used when we have, you know, time series data. Time series data means we have, suppose, year. Here we have some years, and here we have productions, right? So we have years or productions. In this, suppose we want to make a graph where in the y-axis, suppose I'll show you this. Suppose this is a line graph. Okay, in the x-axis we have the years, and in y-axis we have the production. It shows by a line graph. Okay, so I will make this same type of graph in Excel also. So in a line graph can be used to, is very useful for plotting the year-wise production or year-wise things. Year-wise, suppose number of accidents, year-wise number of production of wheat, year-wise production of oil, like this. So for that, let us select the data. Okay, it's not a very tough, but you have to do some tricks for making this type of graphs. So select this, click on line. Okay, this. So this is a line graph. It is okay, but there is a problem. You see, in the x-axis, the years are not coming here. Actually, what happened? The years are also taken in the y-axis. This blue line you see, in this blue line, the years are given, years. So we should put these years in the this x-axis, but it is now in the y-axis. Okay, so what we have to do, we have to do some modification for that. Okay, you getting my point? So you see, in the x-axis we should have the years. 1 means 2000 to 2000, 2 means 2001, like this. But it is, years are gone into the y-axis. This blue line shows the y-axis, this year, you see. So what we have to do, we have to do little modification to put this years into the y-axis. For that, I have to go to select data. Okay, click here. Now you see, start data range. So data range is from A1 to B21. So A1 to B21. Data range is taken as from A1 to B21. So this is the A to A1, and B21 is this one. So from data from here to here again. But for y-axis, only this data should be taken, and this data should be taken for x-axis. You are getting my point? So what we have to do, we have to change this data range, right? So go to select data. Okay, now you see horizontal category axis. It is written here, horizontal axis. If I click edit here, so it is blank. So in the horizontal axis, this is the horizontal axis. So in the horizontal axis, nothing is given here. If we give the data range from A1 to A21 in this data, in this axis level, then it will take the years in the x-axis, because horizontal axis means this is the x-axis. Okay, so let us do it one more time. So what we'll do, we just copy this, edit, and put this value here. Now it should be from A1 to B20, A21. So I change this A. You getting my point? I'll do it one more time. So first of all, what we have to do, I have to go to this area and select data. Now this is my data range. My data range from A1 to B21. That means from here to here. Okay. Now, but this column is for x-axis only, not for y-axis. So I put this from A1 to A21 to what? To in the horizontal axis. So select, copy this, edit this, then A1 to BA21. This is for the horizontal axis. So click OK. Okay, you see now years comes here, but the first year is also coming. It should not come here now, because why? Because I put the horizontal values from A1. A1 is for a year, so I make it 2. So my data actually start from 2. Okay. So you see 2000, 2001, and now it's still in this legend field. So I remove this year from here. So you see now this is the graph. So for plotting time series, you have to do this little modification. If I can show you one more time. So for this, just select the area. Okay. Then go to insert, then line graph, then plot line. Till now it is okay. But my problem is that here comes in the y-axis. It is not coming in the x-axis. So I have to change it. So click here, go to select data. Okay. Now this is my data range, but my data range, actual data range should be from B, because this B column will be in the y-axis. So copy this. So I have to make it to the A. Edit. So put it here. Now I have to make a little change. So B should be changed to A, because this range is from here to here. It is in be in the x-axis. So A1, A2. A1 means it is here. So A2, A2 to A21, it should be coming in the y-axis. Now you see. Now remove year from this. Okay. Now you see this is the line graph. Okay. Okay. Organizer, can we take a 10 minutes
Sure,
break?
sure, sir. I was just going to call you. If you wish,
Okay.
we can take a break of 10 minutes.
Okay.
Okay, sir. Sure. Dear participants, please don't leave the meeting. We'll be back in 10 minutes.
Can we start?
Sir, I think we should start.
Okay.
So you can proceed on, sir. Yeah.
Okay. Thank you.
Yes.
Now, I have shown you how to do analysis on discrete data. Now I will go to continuous data. So in continuous data, what type of analysis we can do? Okay. So first of all, we can calculate the different statistical measures. Suppose mean, median, mode, standard deviation, variance, like this. It can be calculated very easily by using Excel. So age and income, these are the two continuous variable. No? Let us copy it to the another sheet and we will do the calculation here. Okay, so these are the two variables. Okay, so I will use the functions. These are the functions. So for finding the maximum value, we have to use the formula max data range. For calculating the minimum value, I have to use the formula mean, min, data range. For arithmetic mean, this is the formula. For median, this is the formula median data range. For mode, this is the formula. For variance, this is the formula VAR data range. For standard deviation, this is the formula. So these are the formulas I will use. I will show you how to make calculations, right? Okay. So let us first calculate the minimum value. So this is suppose age and this is income. Okay. So I will calculate the minimum value for age here and minimum value for income here. So the formula for minimum value is min, equal sign. I always have to put the equal sign for writing any formula. So min bracket. So put the data range. Data range means it is from age. For age data we have from A2 to A301. So A2 colon A301. Okay. So bracket close, enter. So there is some mistake. I have not written the A here. A. Okay. So 18 is the minimum years. So minimum age, we have included person with minimum age of 18 years. Now for income, I don't need to write the formula. I just need to drag it. So income, minimum income is 0. So there are some values you see here. Some values are there where it is 0. So for maximum value, the formula is max, max, bracket A2 colon A301 comma, oh sorry, A301 bracket. So this is the formula max. This is the data range A2 to A301. Click enter. So a maximum age is, I have included person with maximum age is 87 years. And for income, let us drag it, 89,000. So the maximum income of my sample is 89,000. Then I calculate the mean, arithmetic mean. So formula is average, A-V-E-R-A-G-E, average, bracket, A2 colon A301, bracket close, enter. So 40 is the average age, 10, select this. So this is the average income. So mean, median, then mode, let us write it, variance, and standard deviation. Okay. So median, the formula is MEDIAN, median, bracket, A2 colon A301, bracket close, enter. 38, median is 38. Select this. Mode, the formula is MOD, mode, A2 colon A301, enter. 18 years, 18, mode is 18. Then variance, for variance, VAR, the formula of our variance is VAR. So data range is A2 colon A301. Enter. This. Then standard deviation, STDEV. This is the formula, STDEV, standard deviation. Bracket close, A2 colon A301. Enter. So this is the variance formula. So drag it. Okay, this is the different statistical measures, right? Now we can also calculate the correlation between age and income. Okay, I have forgotten to show you one more graph, that is the scatter plot. I'll show you after this. I will show you how to make scatter plot, and that scatter plot is also a very, very informative graph. It shows the relationship between two variables. Suppose correlation, I think most of the people know what is correlation. Correlation shows us the relationship between two variables, right? Correlation shows the relationship. Correlation. Okay. So for finding the correlation between age and income, I want to see whether with the increase of age, income is also increases or not. Whether the relationship is positive or negative. If the relationship is positive, that means if age increases, income is also increases. And if there is a negative correlation, that means if age increases, income will going to decrease. So it shows us the relationship about the movement of the variables. If one increases, other increase or not. Okay. So for finding the correlation, the formula is correl, C-O-R-R-E-L, bracket. So you see here, the function comes array 1, array 2. This is the array 1 and this is array 2. Okay. So I have to put the array 1 and array 2. So CORREL is the formula for finding the correlation. CORREL, bracket. Okay. So array 1 and array 2. So array 1 means A2 to A301, comma. Okay, array 2 means B2 colon B301. Okay, so array 1 means the data range of the first variable. It is from A2 to 301, A301, and for finding for the second variable, it is from B2 to 301. So this is the formula Click here. So it's a negative. It comes as a negative value. That means it has a negative correlation. That means if age increases, the income will going to decrease. Okay, this type of relationship can be seen with the help of, with the help of using Scatterplot also. Okay, Scatterplot is a way of finding the correlation between two variables. It shows us the relationship between two variables. So I will show you how to make Scatterplot. Okay, so Scatterplot. Scatterplot. So I have, suppose first one, I have to find the correlation between systolic blood pressure and diastolic blood pressure. When we measure blood pressure, we have to count. Two readings are there. One is systolic and one is diastolic. Okay. When doctor measure the pressure, we have two different counts, two type of counts. One is systolic and one is diastolic. Suppose I want to find a relationship between systolic blood pressure and diastolic blood pressure. So this is the systolic blood pressure count of the first person, and this is the diastolic blood pressure count. So I have how many observations? About 48 observations. Okay. So for that, I have to find the correlation. Let us find the correlation first. So CORREL, correl, bracket. It is from, the range is from B2 colon B49, comma. Okay, so it is from B2 to B49. You see, to B49. You see here, B49. Okay, now the second one is C2 colon C49, bracket close. So you see, there is a, the correlation is 0.8 and it is a positive. That means if the systolic blood pressure increases, diastolic blood pressure is also going to increase. We can see this with the help of scatter plot. I will make a scatter plot. So in scatter plot, what we do, in x-axis we put one variable, in y-axis we put the other variable. So let us select the area, select the data. Okay, go to insert, and this is the scatter plot. This is the scatter plot. So click here, this. Okay, so it comes like this. Now you see, till here, till 60, there is no data points. And till this point, there is no data point. If I want to magnify this, okay, this is, if I want to magnify, then we can see a good relationship between the systolic blood pressure and diastolic blood pressure. So let us magnify this area. Okay, so what we have to do, you see, minimum value for y-axis is 0, but from 0 to 60 there is no data points. So actually, if I start the minimum value from 60, then this area will going to be magnified. Okay, so what I am going to do, I want to make the minimum value not 0. I make minimum value 60. For that, I have to select this area and right click, then format axis. I have to select this. Okay, so you come format axis. Okay, you see, minimum value is, I'll make it fixed. Okay, I will become 60, because up to 60 there is no data points. You see, now it is magnified. Now here also, up to I think 70 there is no data points, right? So instead of making it 0, I'll make it 70. So the format axis, you have to select this area. I have to select this area and format axis. So let us make it 70. You see, now it magnifies. Now you can see the relationship properly. Okay, so you see, when my this in x-axis we have systolic blood pressure, in y-axis we have diastolic blood pressure. When my systolic blood pressure systolic blood pressure is about 90, my diastolic blood pressure is about 70 or like this, right? When my systolic blood pressure is about this point, then my diastolic blood pressure increases to about 80. When my systolic blood pressure comes to this point, my diastolic blood pressure also increases to this. That means when this increases, when it is 90, suppose it is 90, my diastolic blood pressure is also small. When my systolic blood pressure moves this way, increases, diastolic blood pressure also increases. That means both increases in the same direction. Both are increasing. If one increases, the other all increases. That's why the correlation comes as positive. So it shows us that there is a positive relationship between systolic blood pressure and diastolic blood pressure. If the systolic blood pressure increases, diastolic blood pressure is also going to increase. Okay, so let us make this scatter plot for, suppose, income and age. So let us select this. Go to insert, scatter plot. Go to insert, scatter plot. You see now, you see what type of relationship is that? When my age is 20 years, my income is around this point. When my age increases to 40, my income around this point, same point. When my income is like this, it is around the same thing. So it's not increasing actually. Okay, whether it may be age 20 years or 60 years, the income is most or like equal. So that's why it is actually, it is in decreasing. With age it is decreasing. That means that means with the age of rise of age, the income decreases. That may not be true for the whole population. This is only a sample, no? So it may gives us some bad results. Not bad results actually. This is based on a sample that may not reflect the actual situations. Okay, then for this we have to test. We have to go for inferential statistics, whether this is true or not. To prove this, we have to go for inferential statistics. This observation is based on a only sample, so it cannot give us it cannot forecast the whole population, you know. So that is okay, right? So this is the way you can make correlation and scatter plot. Now, one important thing I want to show you. In Excel, there are a lot of options for doing statistical calculation. Okay, so if you go to data, data, you see here there is an option called data analysis, right? If it is not there in your computer, so you have to install it. Okay, if you go to data, in this side you are going to see one option called data analysis. Okay, it may not be in your computer, but you have to install it. For installing it, you have to go this point, office bottom, then click here, then go to Excel option. Okay, click Excel option, then you see add-ins. Click on add-ins. Okay, you see analysis tool pack. You have to select this one and click go. Okay, then you can have this data analysis option here. Okay, if it is not there in your computer, I'll show you one more time. You go to this, go to Excel option. Okay, then add-ins, then you have to select analysis tool pack and click OK. Right? Okay, so if I click here, we'll have lot of options for doing statistical analysis. You see, one-way analysis of variance, one-way analysis of variation with replication, two-way analysis of variance, correlation, covariance, descriptive statistics, exponential smoothing. A lot of things are there. Histogram, moving average, random number generation, rank, regression is also here, sampling, t-test, all the things are there. I'll show some of them. Okay, suppose I want to I have also already calculated mean, median, mode, the standard deviation like this. We can calculate this same thing here also by using this data analysis option. Okay, click here. So go to descriptive statistics. You see here you have descriptive statistics. So click descriptive statistics, click OK, input the range. So suppose I want to find the mean, median, mode for age. So just select this and put like drew like this. Input the range. Okay, so it is from A2 to A301. You see, okay. Now you click summary statistics. Click OK. You see, all that calculated in a different sheet. This is mean, this is standard error, this is median, this is mode, standard deviation. All is calculated here. Okay, so it is very easy. I'll show you one more time. So suppose I want to find all the descriptive measures for income. So what I have to do, I have to go to data analysis option. I have to select descriptive statistics. Okay, and click OK. Then we have to input the range. Here the input range is not like this, from B2 to B301. So we can input like this also. Click here and drag. Click OK. So these are the descriptive measures. Okay. So we can do a lot of calculations by using. So I'll show you tomorrow or day after tomorrow how to do t-test and ANOVA in SPSS. We can do it here also. Suppose for paired to sample t-test. Paired, I'll explain what is paired t-test in my upcoming video, classes. So let us do paired t-test here. Click this. Click OK. So let us find some data for this. So this is the pair t-test. So I want to do a calculation with this. I will explain what is pair t-test. Data analysis. So go to pair to sample t-test. Click here. Click OK. Then variable one range. We have to put the range of the variable of the first variable. So select this. Then again for the second variable, we have to select this and click OK. It's very easy. So this is the results. I will explain these results in my upcoming videos. Okay. I think we should stop here because if any questions, I can take it now.
Thank you very much, sir, for your beautiful deliberation. In the chat box, there are some queries, especially recently one is posted. Can you once again show how to add in data analysis? Hello.
Yes.
One is posted. Yeah. One participant, she wants to know. So can you once again show add in data analysis? How to add data during analysis?
Data analysis. Yes. Okay. Go to this bottom, office bottom. Click here. Then go to Excel option. Okay. Click Excel option. Right. Then go to add-ins. Okay. Click here. Then you have to select analysis tool pack. Okay. Then you have to click go, either go or okay. I think you have to click go. Okay. You have to click go. Then this, if I click analysis, okay, I'll show you one more time. Click office bottom, Excel option, then go to add-ins. Okay. Analysis, select analysis tool pack, select go here. Okay. Excel add-ins. Then in this window comes here, we have analysis tool pack. I have already there, so it is it is clicked like this. So click OK. So it will be installed to your computer. Okay. Any more questions?
No more questions earlier.
Okay. I think it is clear to you.
So no more questions in the chat box. But there's a query, sir. Definitely, it's true that it's not that easy to follow you while you were showing the particular calculations and all.
I did not get you. Can you hold
Sir,
your?
can you hear me, sir?
Yes, yes.
Yeah. So it's that because since we have started late, then we could not give you much time so to explain all these particular procedures. Therefore, some participants they have asked if we can share the video and all. Definitely, we will try for that if it can be done from our side. Okay, sir. So if there is no question, then I think we can wind up. Hello.
Okay, we can wind up.
Definitely. Thank you very much, sir, for your detailed deliberation. And special thanks to all the participants for their patient hearing. Due to serious technical issues, I have already mentioned that we could not start our program on time. But as our participants, they have beared with us. We seriously once again like to thank them very much. Before summing up, I'd like to request the participants, please go to your Google Classroom and find the feedback forms and the assignments and kindly fill them up. Okay, thank you very much. Definitely, we will be meeting Sir tomorrow for the 6th session, which Sir will be discussing the basics of SPSS. Hope to learn a lot from you, sir, during that particular session. Thank you very much, sir, for giving us your time, and thanks once again to all the participants. Thank you very much.
Okay, thank you.
Thank you.
Okay.
Okay, we can wind up now. Thank you very much.